Predicting timely program completion of BSIT students using logistic regression analysis.
Graduation is a significant milestone for students, marking the completion of an educational program. Timely graduation involves finishing required courses and earning credits with expected time frame. However, it is not uncommon for some study programs to have students who do not graduate on time. Delayed graduation can increase financial burdens on students and universities. A university success is often measured by the number of students who successfully graduate. And similarly, a student's academic success is determined by whether they complete their degree. Ensuring that more students graduate on time enhances the institution's overall performance and reputation. Universities strive to enhance timely graduation rates, often using predictive systems. By implementing AI technologies, this predictive system aims to provide real-time evaluation and early interventions, allowing PLP to support students at risk of delayed graduation. AI's ability to process vast datasets enable a system to predict graduation likelihood accurately, thereby fostering a proactive educational environment. The model's logistic regression component assigns probabilities, classifying students as either likely or unlikely to graduate on time, based on attributes like gender, family income, behavioral factors, and academic performance. The system supports timely intervention, ensuring that at-risk students receive the help they need to stay on track while promoting academic success and institutional efficiency at PLP.
For the statement of the problem, we aim to address the concern over student retention and timely graduation in BSIT program. Many students face challenges that may delay their progress, and it is crucial to identify these at-risk students early to provide the necessary support. Our first research question is, what factors influence whether a BSIT student will complete their program on time? This question explores the various aspects of a student's experience that may impact their ability to graduate as scheduled. It seeks to identify factors that may affect a student's progress. The second research question is, what methods can be used to develop and implement a logistic regression analysis model to predict the likelihood of timely program completion for BSIT students? This question focuses on the technical aspect of our study. It involves understanding the process of creating a predictive model using logistic regression. The objective is to establish a methodology to classify students accurately based on their predicted graduation outcomes. The third research question is, what early intervention strategies can be proposed based on the logistic regression analysis model to assist at-risk BSIT students in completing their program on time? This question seeks to use the insights gained from the predictive model to suggest specific actions or support systems that can be implemented for students identified as at-risk. The focus is on devising practical, proactive measures to help these students overcome challenges and improve their chances of graduating on time.
Upon logging in as administrator, you will see the dashboard. This dashboard comprises the total number of students, professors, subjects, and admins. We can also see the polar area diagram for prediction overview with 3 labels for the total number of students that will graduate on time, will not graduate on time, and status not predicted. We also have a bar graph for the total number of students and factors influencing their graduation predictions. Next, we have a table listing students who are at risk. The intervention tag is set to no value as we haven't done a process for intervention. Next, we have a table listing the students who will graduate on time. And then we have the list of students who don't have a prediction output. When we click the alert students, it will notify these students to finish the prediction process. and below are the gender distribution diagram and the total number of interventions implemented. In addition to the administrator page, we have the modules for maintenance, users, upload, and archive. Upon logging in as a student, you will see the student homepage. We can see the alert message from the administrator to proceed with the prediction to enhance their learning experience. When we click the Continue button, we will be redirected to the Explore page. On the Explore page, we can see the student information for each needed attribute. And when we click the Predict Now button, this will run the Logistic Regression model to predict the student's probability of graduating on time. When the output is will not graduate on time, we can see the main factors that have caused that prediction output. In addition to the student page, we have a module for grades and surveys. Going back to the admin dashboard, we can now see the latest data for the students who cannot graduate on time. The next thing we need to do is to process interventions. This button will notify the professors of the student who failed in their subject or need additional academic requirements. This will also look at the available events tailored to socioeconomic and behavioral events. We can also see the intervention tag values change into yes. And we can also see the updated information for the total number of interventions implemented. After logging in as a professor, we must navigate to the intervention page. And the professor will be able to see if students need additional academic requirements. The professor can now give instructions and a link for an academic intervention. In addition to the professor's page, we have the module for advisory classes where the professor can input the student grades. Going back to the student page, with the prediction of not graduating on time, an intervention page is generated for them. This contains the additional academic requirements, socioeconomic events, and behavioral events that the students can perform. And once they click the interested button, they will be redirected to the specified link. And this is the PLP system.
Our study shows that logistic regression analysis is highly effective for identifying academic, socioeconomic, and behavioral factors influencing BSIT students' timely graduation. The model demonstrates how diverse elements of a student's experience impact their potential to complete their program on time. Key academic indicators like grades reveal student capabilities and progress, while socioeconomic factors highlights the role of stability and resources. Behavioral aspects such as study habits and time management emphasize the importance of discipline and commitment. With an 86.23% accuracy, our predictive model effectively classifies students likely to graduate on time, making it a valuable diagnostic tool. This enables administrators to target resources efficiently and support students at risk. The analysis shows that the first-year GWA is the strongest predictor of on-time graduation, supported by programming grades, study habits, and motivation. This insight underscores the importance of early academic performance for long-term success. The model helps direct support resources such as tutoring, financial aid, and time management workshops to those who need it the most. This approach supports personalized interventions that improve overall graduation rate. In conclusion, predictive analytics offers a powerful tool for educational institutions. By addressing academic, socioeconomic, and behavioral factors, we can better support BSIT students and promote timely graduation. The promising 86.23% accuracy rate in predicting timely graduation among BSIT students demonstrates that logistic regression analysis is an effective early intervention tool. To fully leverage the system, it is essential to translate these predictions into targeted support measures. Integrating predictive insights into student services will maximize the impact and utility of the model. Establishing standard procedures based on academic, socioeconomic, and behavioral factors can streamline intervention processes. Enhancing the dataset with more diverse student records would improve the model's accuracy and firmness, making predictions more generalized and precise. Regular performance assessments are crucial. Routine validation against real outcomes and necessary adjustments will ensure the model remains effective over time. Expanding the dataset further supports the adaptability to evolving students' characteristics and challenges. Exploring additional analytical techniques may enhance predictive capabilities by uncovering complex patterns not detected by logistic regression alone. Combining results from different approaches could increase the system's accuracy and reliability. Incorporating health data, such as mental and physical wellness indicators, can provide a more comprehensive understanding of students' risk. This additional could reveal connections between stress and chronic health issues and academic challenges. In conclusion, by integrating this enhancement and conducting ongoing research, the system can adopt a proactive, holistic approach to identifying and supporting at-risk students more effectively.